Hello everyone and welcome to another solving session with Special Maths Academy. And in today's session we are going to be covering one of the questions from just concluded senior maths Olympiad second round in Nigeria, problem 13. And the question is written: find for all positive numbers x different from 1, find the value of this expression. So these are the options, and so to do this question really quickly, there's just one one property of logarithm that we should be familiar with, and the property goes like this: suppose a and b are positive in real numbers, because logarithm is only defined when they are both positive real numbers. So log a base b is equals to 1 over log, when you swap it, as b goes at the base and a goes at the top. So now this is just the property we use to easily do this question. So, but first of all, I'm going to just give some reason why this property is true. So just prove it quickly below. It doesn't take a lot of time. So we are used to this, that if log a base b is equals to, let's say, x, then it implies that a raised to power x is equals to b. Because this is how logarithm is defined. Logarithm and indices are like inverse functions. So if log b base a is x, a raised to power x is b, and so keep it here. Then now, if a raised to power x is equals to b, and we can actually go both ways. Like if a raised to power x equals to b, then log b base a is x. If log b base a is x, a raised to power x equals to b. You can go both ways. So now, if a raised to power x is equals to b, then what can we get from here? We can take x root of both sides. So that would be a is equals to b raised to power 1 over x. So a is equals to b raised to power 1 over x. So then by using the converse side, as I said, because I said the side that is without the power and the side that is with the power, you can you can start from both sides. You can start with the log side, you can start with the index side. So from this fact, a is equals to b raised to power 1 over x. What does this imply? It implies that 1 over x is equals to log b base a. Okay, it may not be so familiar, but I'm sure if we started from this side, we can then conclude that b raised to power 1 over x is equals to a. And that's exactly what is here. And as I said, both sides are equivalent. So this is just a simple proof of how to go around this. And this property is going to be really helpful in this question, as you see a few couple of moments. So how can we use it here now? So it implies that 1 over log 3x is equals to log x3. 1 over log 4x equals to log x4. 1 over log 5, that's x base 5. I'm calling the base before the number above it. So 1 over log x base 5 is equals to log 5 base x. So these three numbers here are what we are to add together, and they are both equal to they are all equal to what is on the right hand side. So let's add the right hand side up now. We are more used to this because here the bases are all the same. All the logs here have base x. So addition here translates to multiplication of the numbers of it. So this will be equals to log x 3 times 4 times 5 is equals to log x 60. So this is the answer to this. But if you look at the options, all of them are in terms of inverse. So applying this property again, what will be the value of log x 60? Log 60 base x. It will be 1 over when you swap the numbers. Log 60 now goes to the base and x goes above. So this is the answer. And that is option A. So the answer to this is option A. Yeah, this was a really short one, and it was the necessary thing. The thing that was really important in this question was just this property, and from there we easily did the question. So see you in the next video.